is all about decision-making business processes. So today's topic is decision-making under uncertainty. We have a question that will lead us through this problem. As you can see, we have a table there. The question goes, the following payoff table. The following payoff tables where the table represents what? Profits. We have alternatives and we have the state of nature. We have alternative A1, A2, and A3, where the payoff are under the state of nature. The question goes by state which can be chosen as the best act using the following. Under A, we have maximax, B, we have maxmin, C, you have minimax, regret, or the savage criterion. We have on the D, we have equal likelihood, the Laplace, and hurwicz alpha criterion, where we are given the alpha as 0.4. So as usual, what we normally say, we'll start with the solution. Solution under the maximax, which is our question number A, the maximax. What you should know under the maximax is here the alternatives maximizes on the maximum output. You go back to your table here, you look on the rows, on each and every row, you look for the maximum value. For A1, we had the alternative A1, A2, and A3. When you look across under alternatives, under the rows, alternative A1, we have the payoff, we have 4, 6, 9, and -2. It's common knowledge, if you look here, you look for the maximum. Which is the maximum here? Maximum payoff. Of course, you have maximum payoff, which is 9. You come and write under there 9. Then A2, similar process applies. We have under S1, S2, S3, and S4. The maximum payoff there is under the state of nature S1, which is 7. Under A3, we have on the state of nature, we have 3, 6, 8, and 4. The maximum there is 8. Now, the question was, which state can be chosen as the best act using our case here under A, we are under the solution of the maximax. So you look here, we have chosen all the maximum values under all the alternatives. You have A1, which is 9, A2, which is 7, and A3, which is 8. Now, what you do, you look among all of them, the 3, which will be the maximum, and our best alternative here, the maximum is under A1. When you look at all A1, A2, and A3, A1 emerges to be the highest payoff. So our solution here, it will be A1 is equals to 9, which is the best alternative under this case. Now, that is question A already solved. We look for B, which is the maxmin. You'll come and look there for B. Maxmin, let's do it here. Maxmin. The same procedure applies. But in this case, what do? You first look for the minimum. You look for the minimum. Then, after looking for the minimum, you look for the maximum from all the alternatives that you found to be the minimum. You come and write here the alternatives. You have A1, A2, A3. Now, the procedure continues. You go to alternative A under these sets of nature. The payoff, we have 4, we have 6, we have 9, and finally under S4 we have 2. Which is the least there? The minimum value there is -2. Very correct there. Then you go to alternative A2. We have the minimum. When you look at it, rows under the rows. The rows is what you're seeing here. That's the row. You have 7, you have 6, you have 3, and you have 1. The minimum there, which is the least, is 1. You come and write there, which is equals to 1. Then on number 3, alternative 3. Again, under the state of nature, we have 3, we have 6, we have 8, and we have 4. When you look at it, the minimum there is obviously number 3, which is less than all the values under that row. So we get 3. Now, those are the minimum values under this alternative. What you look from there for you to make a judgment, you look which is the maximum value in all. You see -1, of course not. A2, of course not. So A3, which is assigned to a payoff of 3, means it's the greatest. So the max min will there be best alternative, best alternative, alternative is a 3 with a payoff with the payoff with a pay of 3. Now, question number C, it was the minimax regret or the savage. The minimax or the savage. So we'll come here and say it is under C, minimax regret or savage criteria. What you do here, you come into your table again. Now, on the column wise, under the payoff, you look for the maximum. Then, that maximum, you subtract all the values on that column from the maximum values. So, let's draw it here under S1, S1, S2, S3, and finally S4. Now, here the maximum is 7 under S1. So you get 4 from 7, you get 4 minus 7, no sorry, 7 minus 4, you get 3. Then 7 minus 7 itself, you'll get 0. Then 7 minus 3, you get what? Again, you get there 4. You come to S2. From the S2, you look at it again. Which is the maximum value? All the values are equal. Each is 6. So it will be 6 minus 6. You get 0, 0, and 0. Then to go to S3. S3, the maximum value there is 9. So this 9, you subtract all the values from what? From 9. So we start by itself. 9 minus 9, you get 0. Then 9 minus 3, you get 6. So you write there 6. Then finally you'll have 9 minus 8. Your value there will be 1. You go to S4. Under the S4, the maximum value there is 4. So what do we do? You subtract each and every value from 4. So it will be 4 minus -2. When a negative goes by, you get a positive number. So it will be 4 minus 4 minus -2. You get what? 6. Here your value will be 6. Then 4 minus 1, that is 3. Then the final one will be 4 minus 4, which is 0. Now, what are you looking for? We are looking for the mini-max. There now, you come and look on each and every row, the maximum. So we can say here maximum max of rows. So the maximum of each row, this one it was row A1, this one A2, and this one A3. The maximum of each row under A1, the maximum there, it is 6. And under A2, the same way, the maximum is 6. And the final one, A3, the maximum is 4. Now, once you look at there, we have all the maximum. What do you look from the maximum now? Under the minimax regret, you look the minimum from all of that column. So the minimum will be 4. So our solution or our answer will be the best alternative will be B. Alternative will be A3 with the value of 4. That is our number C based on that question. Now we have that one D, which says equal likelihood or Laplace. A Laplace has a formula where I will say, let's write here D, question number D, Laplace. A Laplace will have a formula where we say N is number of events, and in our case we have S1, S2, S3 and S4, which we'll call the payoff. S1 is equals to the payoffs. So our formula will be, for Laplace, it will be 1 over n into those brackets. You can say S1 plus S2 plus S3 plus S4. Now we'll come here and do what follows. How many events did we have? We had 1, 2, 3 and 4. So our n will be equal to 4. So here under A1, A2, A3 is equals to 1 over 4 into bracket S1 we had 4 plus S2 6 plus S3 9 plus negative 2. What will you get? Plus negative 2. What you'll get, let's take my calculator, even though it's a very simple thing for you to be sure of what you're doing. 4 plus 6 plus 9 plus negative 2. You get 17. When you divide it by 1, when you multiply it by 1 over 4, you get 4.25. Then the other one, again, we'll have S1, you have 7 plus 6 plus 3 plus 1. Your answer will be 7 plus 6 plus 3 plus 1. That is 17 again. Divide by, not divided, times 1 over 4. You get 4.25. 4.25. Then our final one, 1 over 4 into brackets. We have 3 plus 6 plus 8 plus 4. We know which is the best there. It will be 3 plus 6 plus 8 plus 4. You get 21 times 1 over 4. You get 5.25. So part 3, it was the hurwicz alpha criteria. Under that, we have a formula for that, and that's how it will go by. You have a formula for this, and this is how you're gonna do it. You know, for the hurwicz criteria, you'll come and draw that one. We'll have S1 S2, S3, and S4. Here we had under the S1 we had 4, 7, and 3 for payoff. Here we had 6, 6, 6. And S3 we had 9, 3, 8. And under S4 we had -2, 1, and 4. For the hurwicz, we have been given the alpha criterion of 0.4. For the formula for it, it will be the alpha into brackets, the maximum value you have, plus into brackets again 1 minus the alpha times the minimum value you'll find. Now here, come and look for the maximum value, and also look for the minimum value. You look for the maximum value and minimum value on each row. Now when you look here, the maximum value for each row here, it will be 9. Here the maximum for A1, let me put here A1, A2, and A3. Now under A2, the maximum value here, it is 7, and A3, the maximum value on each row, this row is 8. Then the same way happens to the minimum. You look for the minimum on each row. A1 here the minimum, which is -2. Then A2, the minimum here is 1, and A3, the minimum is 3. Now since we have that, and you have been given the alpha at 0.04, this formula, let me put it here so that we can work with it once and for all. We have the alpha, we have the maximum inside, maximum, plus 1 minus alpha times what? The minimum. Here you come and say the alpha here under A1 is 0.4. The maximum value there, it was 9, plus 1 minus 0.4, which is 0.6, times the minimum value, which is -2, which is -2. What do you get the answer? The answer, let's use our calculator, 0.4 times 9 plus 0.6 times -2. What do you get? Here it will be 2.4. Then you'll come here, the same 0.4, the maximum value there is 7, plus 0.6, the minimum value there is 1. You multiply times 1, what do you get the value? It will be 0.4 times 7 plus 0.6 times 1, you get 3.4. Then the final part, it will be 0.4 times the maximum value there. The maximum we found it to be 8, plus 0.6 times what? Times the minimum value of 3. What do you find the value? Let's see. 0.4 times 8 plus 0.6 times 3. You find your answer to be 5. Now, what you have found here, this value is what you're going to base on choosing your best alternative. You look for the highest, and the highest is 5, which is under alternative A3. Now you say the best alternative is A3 with maximum payoff of 5. So as simple as that, you'll have scoped everything and you have the knowledge of decision making under uncertainty. Let's meet next in our next video. As we wait for the next video, you should know that as we make decisions in business, we may find hard times. As we make decisions, you may make some difficult decision or easy decision. That's why you have the knowledge of decision making under uncertainty. Now let's meet on making decision under risk. See you.